Okay, we're picking up where we left off. I hit stop instead of pause because my screen was acting up. So um, this is the second part of the same video. So now, hopefully you've had a chance to look at it and you come up with an answer. And the answer is B because again, you start at the origin. Also, the other thing you should notice is that this is a positive number, which means that eliminates A and D because those are negative slopes. So that kind of goes back to what you learned about positive and negative slopes. And this is a positive slope. So what you need to do is you need to go up 2 and to the right 1. This one, they went up 1 and to the right 2. So the slope was 1/2 instead of 2 over 1. So that's why it's B. So let's keep going there. Okay. And then so this is just kind of sum it up. Okay. They're of the form y equals kx. K can't be 0 because then it doesn't make sense. And it always passes through the origin. And if the slope is greater than 0, it's positive. So that's why it does this. And if it's negative, if it's less than 0. And that's what that's trying to tell you there. So let's go on to the next piece. Okay, so now here's the equation. And basically we want to use what we know in order to solve the equation. So sorry, let me get that up and go back to annotating on my desktop. Okay, so now what we're ready for here is we're going to our equation. So remember, it's y equals kx. So y equals kx. Suppose y varies directly as x, and then y equals 9 when x is negative 3. So 9 equals k times negative 3. I want k by itself so I can write the equation. So I'm going to divide both sides by negative 3. So k is negative 3. So my equation would be y equals negative 3x. That negative 3 comes from this one right here. Has nothing to do with this one. Okay, it just so happens to be that. Okay, so again, I took this equation, I substituted in x and y, and I used it to find k. All right. So we're going to clear that, and you're going to see they're going to do exactly the same thing I just did. Okay. Okay, so now that we have an equation, let's go to the next piece. Now we have our equation, so what we're going to do is we're going to replace the y with the 15 and then use it to find x. Because they're giving me y and I already know what k is, so I can use that to find x. So you have y equals negative 3x. That was my equation. I'm going to replace y with 15 because that's what they told me here in the problem. And then we're going to divide both sides by negative 3. And we're going to find out that x is negative 5. Okay, so we wrote an equation and then we used the equation to solve a direct variation problem. So therefore x is negative 5 when y is 15. That's in answer to the B part. A was actually coming up with the equation. Okay, so now we're going to check. So you're going to do the same thing here. So take a minute and pause it. And then notice that it has y varies directly as x. That's important, so make sure that's there. They give you a y, they give you an x, so use that to find k. Okay, and if you did that, you'll notice that it was 15 divided by 5. I'm assuming you came back. And then so that you end up with 3. So k is 3x. Let me write that out for you. So what we did is we used y equals kx. We said 15 equals k times 5. Divided both sides by 5, so k is 3. And so y equals 3x. That's how they got that. Okay, let's go on to the next piece. Now, they're using the equation that we got previously, which was y equals 3x. Okay, so let's do that one. Again, you can pause. So we have y equals 3x. They're telling me that now they want y to be negative 45. Don't go back to the original. They just gave you the whole thing so you knew where it was from because it's on separate screens. So then we're going to have negative 45 equals 3x. We're going to divide both sides by 3, so x is negative 15. And you should see that the answer is C. Okay? So first you come up with the equation, then you use the equation to find whatever it is you're missing. And they're always going to give you either x or y, and then you have to solve for the other one, whichever one they don't give you. Okay, so let's do that, and then okay, now we have a real world example. So we're still doing the direct variation thing, but now it's in a word problem. So the Ramirez family is driving cross country on vacation. They drive 330 miles in 5.5 hours. So then you want to use the direct variation equation to find the distance driven for any number of hours. And so what you're doing is you're using the formula distance equals rate times time. Hopefully you have seen that formula before. So if you let R equal rate, then it's 330 equals R times 5.5. All right, so when you do that and you solve for the rate, excuse me, you're substituting in, so we're trying to find R. So you're going to divide both sides by 5.5, and you're going to find that the rate is 60. Okay, so now we know our equation is D equals 60T. So keeping that in mind, on the next screen, we now know what the equation is. They ask you to graph it. I would stick with the first quadrant. Remember, you're starting at the origin. You know that the slope is 60. So there you go. And so time is your horizontal axis, and then they did distance in miles. Okay, so that's how you could do that. But notice it's all positive, so it's only first quadrant. And there's a title, and there are labels on both axes. Excuse me. Now, how many hours would it take to drive this distance? So we're going to use D equals 60T. That was our original. 500 represents distance. So we're going to divide both sides by 60. And when you do that, you're going to get 8.33, repeating, it's approximately T. The wavy lines means that it's approximation, it's not an exact answer. That's why they're doing that instead of the equals. We rounded to get that answer. And keep in mind there's all types of rounding. So at this rate, it would take about 8.3 hours to drive 500 miles. So hopefully you're seeing that this is actually a fairly easy thing to do. So here you want to write the equation. And so again, still using the formula D equals R times T. They're just using H for hours instead of T for time, okay? So you write your equation. You're basically going to do 26 divided by 3.25, and you'll find that R is 8, okay? So then once you find that using D equals 8H, now what's the graph look like? So you know it's not D. Okay, so you need to go, if it's 8, it means you need to go up 8 and to the right 1. Okay. Oh, I'm sorry. No, up 60. What was this one? I forgot. Yeah, it was 8. Okay. Up 8 and to the right 1, and that's where you're getting this one. This one, it means the distance doesn't change, so it's like cruise control if you want to think about it that way. Okay. Time doesn't change. I'm sorry, distance is changed. No, distance stays the same, but time moves on. So now, sorry about that. So now how many hours it would take, estimate how many hours it would take to jog 16 miles. So you're using your formula that you got, and let's write that out. And that was D equals 8H, and we know 16 equals 8H. Divide both sides by 8. H is 2. So your answer should be D, which is 2 hours. And that's how you're getting it. We're using the equation that we wrote previously. All right. So let's clear this out. And hopefully this helps, and we'll see you on the next video.